Hi everybody. In the last video we introduced Venn diagrams where different groups were represented by circles. What we have actually done there is very closely related to set theory, which is a branch of mathematics. So each circle in Venn diagrams actually represents a set. A set is a group of items that share something in common. So D in the last video, for instance, was a set of people who own dogs. We can fully specify this set mathematically as well by listing all the IDs of the people who own the dogs. So these numbers, suppose, represent persons' IDs. So these are numeric IDs. So the set of dog owners can now be represented by a list of IDs. And so these are the list of IDs for all those people who own dogs. Some of these IDs are red, and I shall explain later as to why that's so. Similarly, C is the set of people owning cats. And here is their list of IDs. Again, there's nothing special about IDs. I just chose these numbers to represent the IDs of cat owners. You will notice that there are numbers that again appear in red. Now it's easy to see, if you can pause the video, that the numbers appearing in red appear across both these sets, in both C and D. So they are common in both C and D. Therefore, I can write them out separately as a new set of people who own both a cat and a dog. So these people belong both in sets C and D. I think this is a good time to discuss overlap or intersection in sets. So here I repeat the set of people that belong to both sets C and D. I can say they are members of both the sets C and D. Or in other words, they belong to the intersection of sets C and D. This can be mathematically represented as C intersection D, where the upside down U represents intersection or commonality. This is a set with all the common members from both the sets. We can also show this with a Venn diagram. And here are the common members written out in the common or overlapping area. Note, we can use Venn diagrams to showcase either the number of elements in different sets, as we did in earlier slides, or as we did here in this case, where we are writing out the complete sets. For example, in this case, the overlapping area shows the complete set C intersection D with all its elements. Both are okay depending upon what you want, but remember to be consistent in the same diagram and do not intermix both the representations in the same diagram. Now, if intersection represents the members that belong to both sets C and D, union represents members that belong to either C or D. So union unites or combines both the sets into a single set. So here's the set C as before and the set D. Then C union D is a set that contains all the members in C and D put together. Let's see that in a Venn diagram. Since we must combine all the elements in C and D, we write those who belong only to C, those who are common, and those who only belong to D. So all of them put together represent C union D. So therefore, we get the whole set as on the bottom of the screen. Remember, when putting all the elements together, none should be repeated, even if they appear in both sets. So for example, there are these elements in red that are common to both of them, both C and D. They should not be repeated twice when we write the set C union D. Now, while drawing Venn diagrams, we need to know what the universal set is. Think of it as the big box that holds everything we are talking about. So if we are studying two sets, say C and D, the universal set includes everything in C, everything in D, and even the things that belong to neither. We usually show it with the symbol U or sometimes the Greek letter Xi. It's basically the whole universe of objects we are considering for the time being. This situation is visualized in this Venn diagram. Clearly, we can see that everything in C, D, everything that's common, and everything that doesn't belong to any of them all belongs to the universal set U, which is represented by U here. So it's really easy. All the elements that appear anywhere collectively, they belong to the universal set. Now let's find out how many people do not own a cat. It's negation. So in set language, that's everything that's not included in C. Hence, we remove everything in C from the scene. We call this C complement, written as C prime or C apostrophe. It means we take the universal set, that is all the people in our survey, that's U, and remove everyone who owns a cat, which is C. So U take away C is the C complement. So C complement contains all those who only own dogs, as is represented by the elements under D, and all those who neither own a cat nor a dog. So this is shown by the union of these two sets in this last bullet point. And we can finally write it down as a single set as well. These are all the people who do not have a cat. Now let's see another example. So here's another example. Suppose U is the set on your screen. A is another set which contains some of the members of U. Obviously, the set has to be derived out of the universal set. So we remove all the members of A from the universal set, and we get A complement. And the way it is visually organized, I hope it's easy for you to see that we have removed only the elements of A from U, and A complement is comprised of just 6 and 8. So this is also written as U backslash A and is interpreted as U take away A. The situation is also visualized in this diagram. You can pause and watch if you need to. So that's it, and we shall see you in the next video.